All right, so we should be recording now. Awesome. So thank you guys for coming. I'll keep admitting people as they come in. But this workshop is about like going from your CAD files, converting that into something that you can use in your 3D printer. And this specific workshop is more for people who either have some files online that they found and they just want to like process those so they can 3D print them, or they're familiar with a CAD package and so they want to 3D print the parts that they actually designed themselves. And we'll be going over the basics of the slicer software Cura. So for people just completely unfamiliar with this process, you'll get to see the basics. And for the people who are already like somewhat familiar with 3D printing, I'll go into some more advanced settings. Nothing too crazy, but just some little tweaks here and there that can make your prints better or also just have some cool effects. So I do want to clarify though, like I'm not really going to go into the actual CAD design process. I'm just going to assume from here on, like we've created a part or an assembly, and we're going to use that within the Cura slicer and then 3D print that. We'll be having workshops in the future on CAD design specifically. If that's something you want to see, but the specific workshop isn't really about that. Everyone can hear me, right? Just want to clarify. CAD workshops, right? I found out a couple minutes in that people can't hear me. Can I get like a thumbs up or something?
I can hear you.
Yep.
Okay, perfect. Awesome. So we're going to, at the end, we'll go into like the project that we have within the club. So you guys can see Solidworks up right now, right? Just want to make sure I'm sharing my full screen. Yeah. Okay, perfect. So from Solidworks, let's say I'm going to open up a file like so that we can use anything that we can use as a practice. So, right. Okay, hang on. Clicked on the wrong one. It's the one next to it. This one. So let's say you have something created on SolidWorks. I'm just going to open like an old draft we have of a rover for the ASME rocket. When it comes to this, let's say I want to grab this file, this single part, and convert just this part into something that we can 3D print. So the first step towards that would be open your file as it is, as a SolidWorks part, or if you're in Fusion 360, NX, Creo, any of the CAD software, it's the same process. So go into your like save as in the file tab, go into save as, save it as a copy, don't save it as your original. And then let me save this within my downloads. You want to go down into the file types and select an STL, a stereolithography file. This is what the slicer, we're going to be using Cura. This is what that slicer reads. It can't open your SolidWorks parts. It can't open your CAD parts. It has to be an STL file. So go ahead and save that. And now we could import that into our Cura slicer. So I'll go more in depth with this, but just to show you guys what that looks like, here's that part, right? So let me go back to SolidWorks now and also go into, just admitting someone. So also, let's say you have an assembly. So it's not just a single part like that top plate that I grabbed. It's a full assembly of a bunch of different parts put together that you want to save in 3D print all as one. So what you can do, I'm going to suppress this rover before it, makes my SolidWorks crash, because that would be a lot of files. But what you can do is you have your assembly file open and you can go ahead and save that as a parts. If you save it as an assembly or as a, like, if you save it as an STL from your assembly, then you're going to get a bunch of individual part files and it's not going to be what you want. So let me go ahead and save that again in here, this folder. So if I save that as a part file first, and I have to close this and open the new one, so don't save that. Have to open the new one. So now I open this as a part. You'll notice, you click no if the feature recognition. You'll notice now instead of having the individual parts listed on the side tab, you'll have a bunch of surfaces. And SolidWorks is reading this all as one file. So from here, you can save this as an STL. So again, stereolithography STL file. And this should be ready to put into your 3D printer. Now, let's say you found something online. It's not a SolidWorks file. It's a step. It's one of the many extensions that you can open within a CAD software, and you want to convert it. This is one way to do that. Maybe like the file type you have isn't something that you can immediately 3D print, so you can always put it into your CAD software and then go through this process and save it as an STL file with the stereolithography extension. So you can see now I imported that here. Naturally, this isn't really something that we would 3D print, but this is just for the sake of example. You can see that the full assembly is in here as well. So now let's get into this slicer software. So with Cura, the first thing that you'll see once you download this software and get it running isn't this screen. You would actually see something like this, like an add printer. And the reason for that is, well, there's many different types of FDM printers. FDM is fused deposition modeling. That's what we're going over. And they're the printers that kind of like have a spool of plastic and melt it and lay it down layer by layer. So because there's many different types of printers and they have different dimensions and capabilities, the software is going to require that you pick one. So you could always pick one connected over internet, but it tends to also be easier to just click this add a non-networked printer button. And you can scroll and find the printer that you want to use. So for example, with most people, their first printer is a Creality Ender 3. They're pretty cheap and they're good printers. So you can find that in Creality 3D. I have the CR10, the TRX, the different Ender series printers, Ender 6. So I'm just going to select Creality Ender 3 and add that. So depending on the printer that you add, you'll have a different size build surface. And you'll have these blue lines forming like a wireframe box. So that's just telling you the max dimensions that you can print within. So for example, with that part that I opened just a little while ago, you can see it kind of gets grayed out and has these stripes because it goes outside of the max dimensions of the printer. So a couple different things that you can do with this part. Once you have something imported, whatever you want to print, and you have the printer that you own selected, you can always move the part around the build surface. You have to click it first, and then you have this left side ribbon that you can click through the different tabs and do different effects. So you can always, you have your X, Y, and Z, they're colored. You can always click and drag. You can also type values. So if I want it perfectly in the center, I can always type 0, 0, and 0. If I want it 20 millimeters to the right, I can type that in the x-axis. But let's have it in the center for now. You can also go into the second tab in the ribbon. Just to be clear, you guys can always stop me or put something in the chat if you have a question. But if your part is too big and within your use case, you can just make it smaller. You can always scale it down. So for example, right now it's at 100% scale. I can make that half by typing 50 here. And so now it's half as big. Another interesting thing, oh, whoops, get that back to 100. Right now I have uniform scaling on. This is the default setting, but you can also just scale in one direction if that works for you. So if I just want to scale the height down by half, I can do that. So let's get it back to 50 for everything. And let's get it in the center. You can also rotate your part in place, right? And if you click and drag in this third tab, click and drag one of these arrows, you can rotate by 15-degree intervals, clockwise or counterclockwise. You can also click on this third button, select face to align. And let's say I select this face on the side over here, it'll turn that into the face that's like going towards the build plate. So I don't want the part like that, but you can always set up what should be up and down, what should be left and right. You can also mirror your parts. There's more things you can do with that, but for the most part, these three tabs will be all you'll use to kind of set up your part. If you want to learn more, there's always plenty of great resources online, or you can ask us questions towards the end. You can also, if you want to print multiple copies of a part, you can create them by, let me do that again, by right-clicking on your part. It'll open up this like screen, and you can also always click center here if you want to skip over the 000 step. But if you click multiply, you can type how many extra copies of your part you want and insert them into your surface. I'll get more into that towards the end because there's some cool stuff you can do with that. But basically, this would be how you set up where your part is on the surface and its orientation. Now, the next thing, when you first open up Cura, the default settings, it'll be set to these basic settings, so you won't be able to see everything that's available in the software. We're going to start with the basic settings because it's really most of what you'll need to get started with 3D print. But first things first, you want to use a certain material, right? So the most common material that you might be using in 3D printing is PLA or polylactic acid. It's just an easy material to print. It's very, like, it can survive a bunch of different conditions, and it takes very little temperature to actually get it to melt and form your parts. So pretty much almost any off-the-shelf printer can handle that material, and it's what most people will use. And you'll notice when you open Cura, within the material tab, it'll just show you these two options, printing temperature and build plate temperature. So 250, 200 for the nozzle temperature, the printing temperature, and 50 for the build plate temperature. Those are the settings for PLA, polylactic acid. And so it just has them there as a default since most people will use that for the first time. In fact, if your printer comes, once you order your printer, that roll that it usually comes with of sample material should be able to handle these settings. So that's a default. But let's say you want to use another material, then you're going to need to change these settings. You're going to need to go into this material tab, and you're going to, it'll either say it on the roll, like it can take this range of temperatures, or you can also look up on any directory just what's the optimal temperature for this material. So let's just leave it at that. Just to show you, you can change it to 20. Now it's 220 degrees Celsius for the melting temperature on the nozzle. Let me change that back to 200, just leave it as it is. But you'll also notice when I did change it, you get this little like counterclockwise arrow showing. So you can always check those to see what settings have changed from your default. And you can always click that button to change it back. But that's a good little sign to let you know like what you have changed. So we're gonna leave that. The next thing is the infill. And when it comes to 3D printing, you don't really print one solid piece for most of the time. Typically, to conserve material, you'll print it with like a supporting structure on the inside. And honestly, it's better to just slice the part and show you guys what that looks like. So to preview the part, in this Infill tab, I can change essentially this setting. You can see that there's these like beams on the inside support structure. And you can set different patterns for it. So the default is cubic, but let's say I change it to gyroid because I think this one's pretty fun. So once that slices, you guys can see, you can see it's a different pattern. And these patterns will have different effects. Maybe you can get more tensile or compressive strength from some. Maybe some just look nice and you want to use them for like a more artistic application. But honestly, like having done the research, the default cubic infill pattern is the strongest for most uses. So if you just want to use the best one, just leave it as the default. For the most part, that should work. And the other thing is you can change how much of those lines there are. So the default is 20%. So 20% of your inner volume will be full of those. But you can also change that. So for example, now there's a lot more. And if I change it to 5%, we should see that there's a lot less. And there's a lot more you can do with this, but within the basic settings, this is the extent of it. So, I mean, you really don't need more than that to get started, but we'll go into some more advanced stuff in a bit. And then another thing to note is your printer, so you can see the process. Your printer is printing layer by layer, right? And so if it's like extruding out the plastic, if it's melting it and plastic is coming out of the nozzle, so it gets laid down, there has to be some kind of surface to receive that plastic. Otherwise, it'll just fall, right? If there's nothing for it to like catch onto. So, for example, with this bottom surface, it's touching the build plate, it's completely fine. You can see layer by layer how these parts are created. So when it comes to something like that top surface up here, once it starts to print something like what's in the middle here, if the nozzle's melting the plastic and it's hovering over that middle section, it's in yellow over here with the holes, there's going to be nothing to receive that plastic, right? So we need to create some kind of support structure so that the plastic has something to kind of grab onto and not just fall down and not print the part. So we do that with this support tab. You can, normally it'll show you nothing. So once you click generate support, it'll actually show you some more options. You can either generate it everywhere. Let me show you what that looks like. So when you click everywhere, any hole that you have inside of the part, any kind of feature that's like, it'll just fill up every kind of empty space that it sees in the part. So you can kind of see that blue stuff on the build plate is the support structure. Everything tends to be like, everything is like the universal solution. Your part for sure will print if you use this support placement setting, but it's not necessarily going to be easy to take off those supports, especially if they're within certain features that are hard to get into. Once you print something with supports, you're going to have to cut them out, like manually take them off. You get like a set of needle nose pliers or wire cutters, just grab onto it and try to pull it off carefully. And if it's inside of a feature that you can't get into, then that's not so good. So you can also set it to just what's touching the build plate. So for example, in this case, that outer ring does receive the supports, but then the inner section, because there's that box touching the ground, won't have any supports in the middle because the supports won't be, the setting essentially is any kind of surface that's directly above the build plate and there's just nothing in between, it'll fill it up with supports. And for most of the parts that you create, this touching build plate option is better. You should be able to print what you're trying to do. But you'll see. Sometimes you don't need supports at all, and it's good. But if you do need them, there's always this option. And naturally, you can manually place supports, and there's a lot more advanced stuff that you can get into. But that's kind of outside of the scope of this workshop. There's way too much to get into with that. So one thing that we should cover is build plate adhesion. So you'll notice whenever I slice the file, there's this like blue ring on the outside. So the default build plate adhesion, like what helps the print stick to the bed, is this skirt setting, which is this blue stuff you see on the outside. Basically, what this is doing is first laying down some plastic just to make sure that there's good flow going on outside of the nozzle. It's a good way to check if like your nozzle's jammed in the beginning of the prints. And also this skirt prevents kind of air draft from picking up the corners of your print when it's first getting started. So if you just have like a thin layer of plastic on the surface and some wind kind of picks up at a corner, and it curves up, that can ruin your print. So this is kind of a cheaper option to try to fix that, but it doesn't always work. So there's more options provided by the software. So you can select a brim, and that will give you like kind of the same idea. It's just instead of just that little outside ring, it'll completely close in onto the start of the part. And then you can also select a raft. And a raft is essentially, again, just some material on the bottom that will help it stick. But when it comes to a raft, it's multiple layers and they actually go under the part as well. So it'll print this like platform first before it starts your actual print on top of that raft. And this is good for parts with materials that have a hard time sticking to the bed. This does waste a good amount of extra material and time, but it's a good guarantee that your part will print most of the time. But if you can avoid using it, that's always better. You can save some material and time. And the last thing is just your option to have none of that. So if you just feel confident that it's going to print as is, you can just skip all of that. But let's get it back to the script, the default option. So really, those are all of the basic settings. Let's say I keep clicking the slice button on the bottom right corner. So let's say that you have those basic settings and you're printing something simple and you're ready to just like it is how you want it to be and you're ready to just go and put it into the printer. So you click on the slice button and once it's sliced, it'll show you how much time it's going to take to print your parts and also how much material it's going to take. So most rolls of material you'll buy are either 500 grams or a kilogram. So you can see out of that total roll, how much are you going to use up? And this this count of mass actually considers your supports in there as well. So it's a good way you can kind of like jot that down on some paper or on your phone somewhere and just keep track of how much filament you've used. And once that's ready to go, you want, so I'm doing this virtually. Alexander will be helping me kind of show how the printer works, but I don't have an SD card on me. Let me unblur my background. So I'm in my Airbnb right now in another state, but I do have an SD card reader. So this is something that you'll need. It usually comes with your 3D printer when you order one. If you're using the ones in our makerspace, we do have some of these kind of lying around. So essentially, depending on your printer, you'll either be using the big kind of camera storage SD cards or a micro SD. And you essentially just put it in here into like one of the slots, the respective slot for it. And then there's a USB connector. So you can plug this into your computer and save your part onto that SD card. And unfortunately, like there's nothing to read right now because I don't have an SD card I can use. But you would essentially just click on the SD card and save your file with whatever name you want. And you'll notice that the extension is this .g code file. A lot of automation that's based around stepper motors use this G code extension to kind of understand what's going on. All that G code is doing is it's a file type that your printer understands, and it basically tells it kind of move the motors in this direction, this direction, all the while printing at this temperature or whatever, depending on what your machine is doing. But essentially, these 3D printers will work the same as a lot of the other kinds of similar devices like a laser engraver, a CNC router, mill, CNC lathe, like all of those machines that just by themselves create parts and manufacture stuff, kind of work with the same file extensions. So, Alexander, can you give me like a heads up if you're ready to go? If not, I'll cover
Yeah,
some
I'm ready to go.
Awesome. So Alexander is going to take over now to just kind of show you guys the process of how to use the printer in practice.
I don't know if you can see the screen or not.
Yeah, I can see the screen. Let me stop my share so people can like pin me. Yeah.
All right. Basic setup. All you need to do is just turn the thing on. If you want to do preheat, you have an option for preheat. Just go over there down to temperature.
Alexander, we can't really see the screen right now. It's kind of bright.
Better or worse? Can you see it now?
No, it
Hello?
still looks like white. Can you get closer to it?
Is it better?
No, it's just completely white.
Yeah, I don't.
Right. Okay,
I
that's
think
just
it's
the
just
screen.
right. Yeah.
That's just Zoom. There's not much I can do about that.
Sure.
But just under your options, you go to screen information. You go just go over there to temperature. You change your settings. You tell it preheat whatever material you want, and you can go to print from media or print from SD card, and just select the file that you want.
So while you leave something printing, David, since we saw that we could see the screen earlier, if you're still on your phone, do you think we could show the printer?
Let me see if I can connect on my phone in a quick second, and I'll go over there.
Sure thing.
Yeah, my phone's not the best, so
No, no problem. Either way, like if we can leave something printing just to show that, that'd be good. Like we can show how to set up a print on David's screen. It's just that printer isn't level right now, so it wouldn't be able to print something more.
yeah, but all I could really do much because this. Remember, I'm on FIU Wi-Fi,
Mhm.
so anything going through FIU Wi-Fi gets distorted.
That's true. Yeah. Yeah. Once it heats up, could you leave a part printing just to show kind of what that looks
Yeah.
like? David, let me know if you need some more time. I can cover
I'm
some
trying to
more.
get on again. Can you hear me?
Yeah, I can hear you.
Okay, give me 1 second.
Can you get a little closer? It might be the same.
Yeah, I got you. It's just, I'm trying to, okay. There we go. So
There we go.
when you turn it on, it'll usually be on the screen. If you click down, you can go to control where he said temperature, and then you can set either of these for whatever you want it to be. So you could just go, oh my God, all the way to like 200 for the material that you had. And then you just, when you get to that temperature, you click down again, and you can set the same thing for the bed and so on. You can click back, you have in prepare, you can have it to move to the auto home so it centers. Is there anything else you want to show them?
Can you click on the auto home just to show what that looks like?
Okay.
So if here, let me share my screen real quick. So back on Cura Slicer, you'll notice this origin, like the 3-axis origin. So essentially, when you click on auto home right there, he moved the nozzle to that origin. So another thing, David, we could show them this real quick. I'm gonna get more into this in the advanced settings, but like once we start, the only real way to change your print speed on these printers at least is, can you go to control and go to motion? So you can change your speeds, and like this goes more into like your actual printer settings. But if you want to print something a little slower, maybe like you notice that it's printing a layer and it's like pulling away the material, it doesn't have enough time to like set it down, you can also change those speed settings on the printer. We can technically do it on the slicer, but I haven't had the best results, at least with these Enter printers. It doesn't always register that I changed the speed, so you can always manually change it there. But like, I would assume for most of your prints, you don't need to do that. It's just, we're going over that just so you know it exists. If you ever get into a situation where your print is maybe failing because it's going too fast, you can always kind of Google around and find out what the right settings are for your printer speed. Okay, thank you, David. That's another sense of it. Oh wait, actually, one more thing. Sorry, just close your share. Can you like close in on the little box to the left, like on the bottom? There should be an SD card. Like you see it, right? The SD card there. Can you click it out? Like you just push it in, it should pop out. Yeah, so you'll see that slot. Once you saved your file onto the SD card, there's always a slot like that that you just put it into the printer. And that's how you get your parts in there. Okay, awesome. So thank you, David. That's all. Well,
You want to show the printer printing?
yeah, can you go ahead and do that? So let's say it was running a file. You would, like Alexander was showing earlier, it would just be printing like this. It's following those lines that we were showing earlier here. On the slicer, it'll show you layer by layer what it's printing. It's just copying that over like in real time. So when it comes to this step, there's a lot more we can get into, and usually this is the point where you'll like things start to go wrong. Like you'll have a bad start to your print, things won't stick. And like maybe something on your printer isn't tight enough or whatever. There's a lot of maintenance that goes into these. So unfortunately, that stuff is out of the scope of this video because we are not in person right now. But we do want to have a more in-depth workshop on that aspect of it in the like near future, so you guys can get more hands-on with the printer, actually run a file yourselves, and then like get to see what the basic maintenance is, what can go wrong with the printers, and know how to fix that. So, Elises, to answer your question, with these Ender 3 printers, it's a micro SD card. But some printers, like we have an Ender 6 in the makerspace, they take the full size, like regular SD cards. As far as I'm aware, there's only really those 2 sizes, but I could be wrong. Yeah. Okay, so thank you, Alexander. I'm gonna go ahead and go into the advanced settings on Cura.
All right, is that it for me, or?
Yeah. Thank you so much. Good to go.
All right.
That out.
Take care. Be safe, guys.
Absolutely, you too. So, like I mentioned earlier, we were on the basic settings. So this is your default settings once you open up Cura. To get into some of the more advanced stuff, you can open advanced, expert, or all. I'm just going to go into all. Naturally, I'm not going to show you guys everything because there's just too much. and I don't even know all of this myself, but you can actually change certain things. So for example, now by clicking all, it'll give you more options for the quality. So one thing that you might find out as you get into 3D printing is that there's different nozzle sizes. So the default one is 0.4 millimeters in diameter. That's the diameter where the filament's going to be pouring out of. And that's the width of every layer that it prints, right? So if you're going to use a nozzle that has a bigger hole or a smaller hole, you can change that on the slicer and you can get different results on your print. So the kind of general thing to know about that is the smaller the diameter of your nozzle is, the higher quality your prints are going to be because you can get more detail, right? But it's also going to increase the amount of time it takes to print your part because every layer is smaller. And then the opposite is true for bigger size nozzles. So if you have a bigger size nozzle, you'll get like less quality to your print. It'll be more like rough looking, but it'll print significantly faster. So if you have to print something very large and you don't necessarily need a lot of detail, it might be good to change the nozzle for a bigger one. And then you can go into this setting, line width, which is available once you click on that expert or all button. And you can actually change that. Usually there's many different sizes, but naturally, like usually the biggest one you'll be able to buy commercially for these kinds of printers, the Ender series and most of the hobby ones that people have, is a 1.2 millimeter nozzle. You can also usually get down to 0.2 or 0.3. It's showing me that it's red right now because I haven't changed other settings, but this is just for you guys to know that this exists. You can change your nozzle size. And if you also want better layer quality, the width, so the width is based on the diameter of the nozzle, right? But then the height of each layer, like the actual thickness off of the bed that it prints, is based on how much material is flowing through the nozzle and how fast it's moving. And you can actually change that here. Naturally, it affects other things, but you can make it bigger or smaller depending on how much detail you want, and your part will print faster or slower. But you know, to make this layer height work, your slicer is going to assume a lot. So I would focus more on this nozzle width if you want to mess with that. And there's very rare cases you'll run into where it might be worth changing that layer height, but just so you know that does exist and you can change that. So let's get as far as quality. As far as infills, you can get into a lot. I'm not going to go into these, but you can get into how thick the infill layer lines are, how much support there is generated for those. You can get into some fancier infill patterns if you kind of upload them into this printer. This is way out of the scope of the basics, but this is more just so you guys know that this exists and you can do this. You can also change, for example, if I set one, but let me do that with the side layers. So, okay, well, top layer is fine. So for example, by default, once it finishes that infill, it'll print 4 solid layers of just material to kind of finish up the part and give it the rigidity it needs with the infill. But if I change that, it might be more visible with the bottom layer given this part. So if I change that, I can get less of those layers going on, and your part will be less rigid. It'll start the infill immediately. So from 1 to 2, change that to 2. You'll see that on the second layer, it already started the infill. And once I go back to the default, it'll take up to the 5th layer to start the infill. This is more than anything, you'll be doing this to increase the rigidity of a part. So if you have like a big block that you're trying to print, like this bottom piece, sometimes you can get away, or most of the time you can get away with a lower infill so that your part is very light, and then just increase those top and bottom and side layers So increase them up to like 5 or even 8, and you'll get a significantly stronger part using less material. But you don't need to mess with this to get a functional part. Again, it's just like a quality of life improvement. You can use this if you want. You can look into it. There's more you can get into with the material temperatures. Not gonna go into that. Like I mentioned, you can change the speed on here. I'm not gonna go into that this time. Like you can type in whatever you want, but when it comes to these Ender 3 printers, it's better to just change that manually on the screen that we were showing you earlier on the physical printer, because sometimes with those Ender series printers, like the G code that the printer is supposed to be reading for the speed setting, it's not registered. So if you have a different kind of printer, like a Prusa, or like a MakerBot, I've had better experiences with those. So maybe you can use this print setting and just slow down your prints if it's not sticking, or if you're like extra ambitious or you're printing something for like a company and you need to produce a lot of units of something and you want to do it fast, you can also try increasing the print speed. And in some cases that'll work. There's again more you can go into with the supports. You can manually place some. There's way too much to go into that outside of the scope of this video. And then one thing I do want to show you is, for example, let's go back to how I mentioned in the beginning that you can have 2 parts within a slice file. So if I were to slice this as it is, this is a good setting for everyone to know. And this is something that you can just implement with the basics. If I were to slice this as it is, it's going to try to print both simultaneously. So once it finishes the layer for one, it's going to hop over to the other and start that. And there's a lot of chances between that kind of hopping around for it to mess up your print, for something to unstick, for extra material to kind of like drip out of the nozzle while it's moving between and kind of get it to your parts. So get like less detailed parts. So this isn't the best setting. To alleviate that, you can use this within special modes. And this is only an option that's available if you have your advanced settings on. You can actually change the print sequence to 1 at a time. And it'll print 1 part at a time. Naturally, I think these are too big right now for it to show that. So I'm going to shrink these down to 10%. Center that. Then 10%. Can move this here. Enter it here. So if I go into prepare, hopefully I don't get an error. Okay, well, I got an error. Ideally, I'd have to do some troubleshooting here to see what's wrong. But ideally, this would allow you to completely print one of them in place and then start the next one after you're finished printing the first one. Let's try that again. Okay. Try moving them to the corners. But yeah, that's a good setting to know about. It especially works with simpler parts. I don't know if I can open up something. Yes. So when it's yellow like this, it means that it's good to slice. Like I mentioned earlier, if you see this kind of like grayed out thing, then maybe it's not ready to slice yet. Oh, whoops. So let me see if I can put 2 of those blocks in to show you guys what that looks like. Scale them down. So 20%. Okay, so they're both yellow now. So let's say these were my 2 parts and they're both yellow. I place them around the build surface however I wanted. And I have that 1 at a time print sequence thing set up. Now it's going to fully print that small one first and then fully print the other one. So this is usually just better for quality. If you're going to print the same thing over and over again, this is definitely a setting you want to start to do. Okay. And that's really, I mean, again, there's more you can get into. You see all these extra tabs like mesh fixes, experimental, dual extrusion. That it depends on what's available on your printer. So not all printers can do everything. And then as well, like you can look more into that. There's just way too much to get into, but if you're curious, you can always look more into that with the slicer. Okay, so that's kind of it for the slicing part. You guys saw how to convert a CAD file into an STL, a CAD assembly as well. And then you also saw how to import it, select your printer, select your settings, and how to, like, at least a quick crash course, rough version of how to use the printers. So again, we'll get more into depth with that, like how to actually operate the printers and do maintenance on them in future workshops. But just so you guys know, as far as a club goes, we are trying to initiate a humanoid robot project, something to, like a project to have to 3D print as a club. So it's not just us printing random stuff. I've definitely had fun printing like random little things. I've printed like a Pikachu with the Rock's head on it. Always fun, but naturally this is also used for serious reasons. And you know, as engineers, we tend to prototype with these printers. We print our parts for senior design. We print our parts for different projects going on. And even at work, there's like out in the field, there's plenty of examples of companies using these 3D printers within their prototyping, and even as far as like for final production printing parts. So within, as a club, the project that we want to start is this Inmoov robot. It's an open source project available online. And you can see on this map, it's a pretty popular project. Every one of those little red dots, like the nodes, are someone that's completed the project. So they've 3D printed one and uploaded, like the fact that like, hey, I've actually finished up one of these robots. So all across the world, people are making these. And it's not just like a physical frame of 3D printed parts. It has plenty of sensors, a camera, a speaker system, and it can basically interact with people, talk with them, and give real responses based on like a Google Voice API kind of thing. It can identify objects using computer vision, and it can actually move around the arms and pick up objects and operate them. So the only thing with this robot as it is that it can't walk. There are motorized versions of the legs, but so far, all the people working on this haven't figured out yet what's the best system that they could use within like the computer that it has and all to kind of get it to walk with stability, so it doesn't just take a few steps and then like trip over and fall. But that is something that we might get into in the future. So as far as a club, we do want to start just our club 3D printing all the parts and ideally assembling them. So as far as those future workshops on how to operate the printers, if you come to those, we'll essentially give you guys again like a quick course on how to use the printer, how to maintain it, and then you guys will get an opportunity to actually print something and like leave it printing. And ideally, over a few workshops or just meetups, if you guys are interested in this project, we will print parts for this robot so that we can in the future assemble them. And we do have the filament within our makerspace, and we have several Ender 3s and Ender 6, just different model printers, CR30. We're working on a Voron 2.4, but just different model printers that we can use to kind of achieve this project. And in the near future, ideally, we can use this, at least bring parts of it, if not like more full assemblies, to our community outreach events. Both like tabling events at FIU, events where people come into FIU, like companies and stuff, to see what we're doing, and as well just the K through 12 outreach events that we do every semester to kind of try to like promote STEM education and like pursuing higher education. So we can kind of bring that robot, because a lot of people, including myself before I came to college, I thought 3D printing was just for like kind of making like little knickknacks and like fun, like small figurines and stuff, but I didn't really think about it as like a prototyping tool. And so it'd be good to show someone like a real example of that in practice. And in the far future, once we have a more complete robot, and if there's interest in it, you know, if there's a team to get behind it, we can get it to do cool stuff. Like there's a person online who's published their results here. Just made this. People have gotten this Inmoov robot to serve coffee and mix cocktails. There's a competition for like a robotic bartender. And then there's also just different events around FIU where we can have it do stuff like this. And it's just like a fun little project, interact with people. It can actually have a full conversation with you. Maybe don't ask it like really advanced math questions, but it can, answer basic things. It can give you the weather, directions. It's pretty cool in that respect. And as well, in the very far future, if there's if there's a way that we can get it to walk, we can design some new legs for it, get the right kind of motor set up, and write the right kind of scripts, the code for it. Maybe a team in the future can use this robot to kind of compete in these robotic soccer competitions or something like that, or just like I mentioned, the bartending one, just something fun to apply that robot to. And so the last thing in that regard, what do we need from you if you want to participate in that, or if you just want to get more familiar with 3D printing and kind of use our equipment to print something that you have as a project. If you could please scan this QR code and join our Discord. We will be publishing more information on there. It's a pretty new Discord, so it's a little empty right now, but we're just trying to get people into it so that by fall semester we can officially start to have everything on there and be publishing our information, updates on our projects. So please join the Discord. There's a 3D printing channel on there, and we'll be publishing more information about those future workshops and our progress on this project. And by fall semester as well, we're kind of getting that organized so we can see like logistics and supplies and all right now. But we're definitely going to be starting on at least one of the hands and forearm of this project. So we'll be printing all of these little components. There's a little over 40 of them, and essentially just assembling them together with the screws and the motors, and using like an Arduino and a quick shield, just some little setup that we've already tested in the past to try to see if it's moving properly, if we did it correctly. So I'm going to leave this slide up so that you guys can scan the QR codes, or people watching the recording in the future can. But does anyone have any questions? Is anyone in the chats? Yeah, so Alex, we're going to be publishing this recording on YouTube. So we do have an SME FIU YouTube account, kind of just like that, SME FIU. I can't guarantee that it'll be up by today because I need to get access from our member who owns the account. But once it should be up at least within 2 days, ideally. And so you can always watch the recording then. If you really need it quickly for something, then you can always just contact me in the club, like the WhatsApp or Discord, and I'll send you the recording. Any other questions? I'm gonna go ahead and stop the recording.